Good morning to you all. Today we are going to discuss an important part of your uh, O-level exam in paper 6, sorry. And this is plotting graph plots or making proper graph plots. Typically in question number 1 of the paper 6, you will have some kind of readings and you will be asked to make a graph plot. Okay. So it will always be good if you can practice as much as possible on how to make proper graph plots. What we are going to do is we are going to have a number of examples, and see how we are going to choose the scale and how we are going to represent the data on the graph. So let us get going. This is question number 1. He's telling us plot a graph of A on the y-axis, B on the x-axis, and this is very important. You don't need to start your axis at the origin, 0 and 0, okay? And this is actually very important, okay? You will typically have or be asked to either start your graph plot from the origin, 0, 0, or you don't need to start. So please make sure that you follow this instruction. The first thing to actually do, I always see it as a good practice. Here we have our table. Okay, we have A and B. So what I'm going to do? I'm going to label the axis or the columns over here. I'm going to say this as I instructed. It is y-axis, just to remind myself, and this is the x-axis. Okay, now I'm going to make a label my graph, the axis on my graph. Okay, so on the y-axis I have A in centimeters. Sorry, in centimeters. On the y-axis I have B on with centimeters. So you make the simple for the axis, and you also put the appropriate unit. Okay. Now let us see how we are going to proceed. We don't need to start from 0, 0. Okay. Now let us look at the x-axis. We have data points. Maximum is 39, and the minimum is something like 21. Okay. Remember always that in the graph plot, most probably are going to have a graph similar to this one, or the graph paper is going to look similar like this one. It has 5 squares. This is 1, 2, 3, 4, and 5 on the x-axis, and 5 on the y-axis. 1, 2, 3, 4, 5. Okay, so 5 on the x and 5 on the y. Okay, now how to choose the appropriate scale on the axis? Okay, let us do it like this. So do it like this: maximum minus minimum, and then divide by the number of squares. Maximum minus minimum divided by the number of squares. Okay, so the maximum on the x-axis is 39. The minimum is 21. How many squares do we have? We said we have 5 squares on the x-axis. So let us do the math. We have 39 minus 21 divide 5. What do I get? I get 3.6. 3.6. Okay. So we are always recommended that a good scale is one which is multiple of 1, meaning it is 1, 2, 3, 4, 5, for example, or 15, 16, 17, 18, 19, and so on and so forth, or multiple of 2, multiple of 5, or multiple of 10. Okay, it could also be multiples of 50, of 20, multiples of 10, but it is not a good thing to have multiples of 4, no, 15, no, 13, no, 6, no, things like this. These are considered to be a good practice for, or a good choice for our scale. Okay. So what did I get over here? 3.6. 3.6 is not going to be a good scale for me. What is the next possible good scale? It is not going to be 4. 4 is not considered to be a good choice for a scale. What is the next best one? It is 5. So I'm going to say 1 square is equal to equivalent to 5 centimeter on the x-axis. Meaning what? I'm going to start from 20, 25, 30, 35, and this is 40. Okay? This is how we choose our scale. If we take a look on how our scale, how far our data point is going to extend on the x-axis, it is going to be from approximately from here to here, extending almost 4 squares out of 5. Okay, almost 80%. Okay, what about the y-axis? Let us see, we have 25, 30, 35, 40, 45. Okay, so we can start from 20, going to be 25, 30, 35, 40, and 45. Again, our data points on the y-axis are going to extend from around here to around here. Again, 4 squares on the y-axis. Okay, then this is considered to be a good extent over of our data points on the y-axis. It is not accepted that, for example, the data point should be only on these 2 squares. Okay, at least it should be 3 squares. The minimum is 3 squares in both directions. If the number of squares are 5, almost more than half. Okay, a little bit more than half the squares your graph need to extend over more than half the squares in both directions, the x and y axis. Okay, so let us start making our data points. So we have 39. Where is 39? 39 is over here. Okay, we know that from here to here, each small square is 0.5. So this is 35.5, 36, 36.5, 37, 37.5, 38, 38.5, 39. So it is over here. And on the y-axis, it is 45. So it is, data point is over here. Okay. What about the other point? 34.4. So 34, we have it over This is 31, 32, 33. This is 34, and a little bit in the middle between 34 and 34.5. So it is approximately over here. So it is 34.3, and we have over 40. So it is around here. Okay. Now we have 30 and 35. This is easy. Is over here. We have 25.2 and 30. So this is 25. This is 25.5. So it is over here. Okay. We have 21.4 and 25. So this is 20. This is 20.5. This is 21. And it is between 21 and 21.5. So it is around here. Okay. So this is our data points. We have graphed or plotted our data points. So let us make the draw a straight line. So make sure that you use a very sharp pen. It is recommended to use an HP, a good quality HP pencil. Okay, never use a pen on your graph rod, neither for plotting the data points or putting the scale or drawing the a line on the graph. Or on the graph, always make sure to use a pencil. Always make sure to use a pencil. Again, you need to have a 30 centimeter ruler. It need to be clear, from clear plastic, so you can see from underneath. Okay, to make sure that you can use it to align your data points. Okay, so this is how I draw my line. Then I just move it till I get a good fit line. Okay. Okay. Now I could see one of my data points is a little bit further away. So if it is a little bit further away, it is not a big problem, but it is worth cross-checking it again. Did I plot it right or I missed it? Okay. So this data point, which looks a little bit further away, it is 25 and 30. 25.2 and 30. Yes, it is. This is fine. Okay, so I just leave it as it is. Now we are asked to calculate the gradient. Determine the gradient of your line. Show clearly on the graph how you obtain the. So to calculate the gradient, you have to draw a right angle triangle. You need to draw a right angle triangle along your line. Okay, the triangle need to be of an appropriate size. Okay, it shouldn't be small, but it should be large enough. For example, like this. Sorry. Okay, so how do we calculate the gradient? It is delta, the change in y, delta y, and delta x. For delta y, let us take the points. So the point is over here. This is 40, 41, 42, 43, 43.5. Okay, and over here it is 27.5. Let us do the counting. This is 25.5, 26, 26.5, 27, 27.5. So it is 43.5 minus 27.5. What about the x-axis? It is 37.5 over here. And over here we have 22.5, 23, 23.5. 37.5 minus 23.5. So let us do the calculator or use our calculator. Uh, 43.5 minus 27.5. It is 16. Okay. And 37 minus 5.5, it is 14. Okay. It is 14. So the gradient is equal delta y divide delta x is equal 16 divide 14. So 16 divide 14. It is 1.14. 1.14. We now check the units. Okay. So delta x is in centimeter. Delta y is also in centimeter. So it is centimeter divided centimeter. The gradient in this case doesn't have any units. Okay. Make sure to know the sign of your gradient. Okay. This is very important. Okay. So if you have a graph plot which looks like this, sorry, which is like this, like this, like this. These are all positive gradient. If you see a graph plot which looks like this, okay, then this one is a negative gradient. Okay, so we are done with example number 1. Let us go and do example number 2. Plot a graph of P on the y-axis. Again, it's 1 over x, centimeter minus 1 on the x-axis. Start both axes at 0, 0. Now, in this example, he told us to start our axis on 0, 0. What do we need to do first is to calculate 1 over x. Okay? Now, let us do 1 over x. So it is 40 minus 1, 0.025. 0.025. And now we have 3 significant figures over here. So we need to keep here again 3 significant figures. How many significant figures do we have? 1, 2, and we have 3. So we add an extra 0. Okay? $27.037 0.0374. 20, 0.05, 0.05, and we need to give it 3 significant figures. This is 1 significant figure, this is 2, this is 3. 15.9, 0.0629, 0.0629. Okay, the last one, 13.3 minus 1, 0.0752, 0.0752. Okay, we are keeping it to three significant figures since we have in the original value of x three significant figures. Okay, now let us choose, label our axis. P is on the y-axis, 1 over x is on the x-axis. Okay, so we have 1 over x, centimeter minus 1. We have P in newtons. Okay, and we need to start from 0. So starting from 0 on the y-axis, we have minimum 0.250 and 0.750 is a maximum. But since we are starting on the from 0, then the minimum is going to be 0. This we were instructed to use maximum 0.0752. Okay, then the gradient, the scale is going 0.0752 divide 5. Why 5? Because we have 1, 2, 3, 4, 5. Okay, remember that. This is how we choose or calculate our scale. So 0.0752 divide 5. What we are getting, 0.015, 0.015, 0.015. So a good scale to go, definitely 0.015 is not a good scale. A good scale to go is to go 0.02. So this is on the x-axis. Okay. Going 0.015. It is not a good scale. The next best scale to go is 0.02. So 0, 0.02, 0.04, 0.06, 0.08. Okay. On the y-axis, we have 2, 3, 4, 5, 6. Okay, so another, we are starting from 0, 2, 4, 6. Okay. Okay, so let us start plotting. Now we need 0.0250. Okay, now it might not be easy counting these values on the x-axis. So how do we do that? Okay, notice that this value 0.0250, it is between here. Okay, it is around here on the x-axis. So how we decide? We check what is the closest scale mark to this value. It is 0.02. So do it like this: 0.025 minus 0.02. I divide by what? I divide by the scale on the appropriate or the relevant axis. What is the scale on this axis? It is 0.02. So I divide this by 0.02. Okay. Now let us do the math. 0.025 minus 0.02 divide 0.02. How many squares? This is how you read it. 0.25. Okay, check this one. The first number after the decimal point. The first number after the decimal point. This tells us how many small squares we need to count. Okay, so we need to count from 0.02 to small squares. What about 0.5? This 5. Okay, this tells us how close we are to the 2 mark to the 3 compared to the 3 mark. Meaning what? Let me show you. So we have, let me zoom in a little bit. Let me zoom in a little bit for you to understand what I'm saying. So we have 0.25. So we are going to count 2 squares. 1, 2. Okay. And 5 means it is midway between 2 and 3. So it is here in the middle. Okay. So this is 0.025. Okay. And the point is 2. So it is around here. Now the next point is 0.0374. So we know 0.374, it is around here. Okay. So let us do the math again. We'd like to plot 0.0374. What is the closest scale mark on the x-axis? Closest to this value, it is 0.02. What we're going to divide? 0.02. So we have 0.0374 minus 0.02 divide 0.02, 0.87. Again, how do we read that? It is 8 square mark, small squares from the 0.02. And what does the 7 means? It is closer to 9 squares than 8 squares. Okay. So on the y-axis, we have 3. So this is the 3 mark. Let us count. 1, 2, 3, 4, 5, 6, 7, 8. It is closer to 9 than 8. So we put it over here. Okay, see how we are doing that? Now, this one is easy. 4 and 0.5. This is 4. This is 6. Midway is 0.05. And we have 4 over here. So this is easy. Okay, now we have 0.6929. 0.629, it is somewhere over here. Okay, so how do we know that? 0.0629. What is the closest scale mark? It is 0.06. We divide by 0.02. 0.0629 minus 0.06 divide 0.02. 0.145. 145. Again, where do we read? We take this first, meaning it is 1 square mark. Okay. How do we use the second decimal place? It is 0.15. So it is between the second square mark and the first square mark and the second square mark. Okay. And where is 5 on the y-axis? It is over here. So it is 1, 2 in the middle. Okay. What about this point? 0.0752. 0.0752. So it is between those two. Okay. So minus 0.06 divide 0.02. 0.0752 minus 0.06 divide 0.02, 0.76. Okay, meaning what? 7 small squares on the x-axis, and it is closer to the 8 square than number 7. Where is the 6 mark? It is over here on the y-axis. Then we start counting. 1, 2, 3, 4, 5, 6, 7. Okay, and this is 8. So it is between 0.7 and 0.7 mark and 8 mark. It is closer to the 8 mark than to the 7 mark. So okay. So here are data points. Okay. Now let us make a graph. We know that it crosses the 0 or passes through the origin. So we need to make sure that it passes through the origin. Okay. Now we are asked to calculate the gradient. Let us make a right angle triangle to calculate the gradient. Okay, this is our right angle triangle. Again, the gradient is delta y and delta x. So what is delta y? So this is value is 5, 5.2, 5, 5.2, 5.4, 5.5. Because this data point is 5.5. What about this? This is 0, 2, this is 1. Okay, so the delta y is 5.5 minus 1. It is 4.5. What about the x? 0.06. This is 0.07. What about this value? This is 0.01, 0.012, 0.013. 0.057. So what is the gradient? 5.5, sorry, 4.5. Divide 0.057. $78.95. Now we need to check the units. Okay, it is the unit of the y-axis divided by the unit of the x-axis. So it is Newton per, and we have centimeter minus 1, and we again inverse it once more, so it is centimeter. Okay, now we are done with this part. We are asked use the graph to determine the minimum value of P required to balance in this experiment, x maximum, the maximum possible value for x is 50 centimeter. Calculate 1 over x. So 1 over x max. X max is equal 50 centimeter. Therefore, 1 over x max is equal 1 over 50. 50 minus 1, 0.02 centimeter minus 1. Okay. Use the graph to determine the minimum value of P required to balance the meter ruler in this experiment. Okay, so the minimum value of P corresponds to the maximum value of X. The minimum value of P corresponds to the maximum value of X. On the graph, we don't have X, we have 1 over X maximum. Okay, so we come over here. This is 1 over X maximum. It is over here, and let us read the corresponding value. Over P over here. Okay, so it is going to be 1, 1.2, 1.4, 1.6. The value of P, the minimum value of P is 1.6 Newton, corresponding to the maximum value of X. Okay, good. Let us go to the next example. For each value of M, calculate and record the values for each value of M, calculate and record in the table the value S, where S is equal A divide B. Okay, so we need to calculate S divide B. We are going to make a graph plot of S and the y-axis. This is going to be y-axis, and M is going to be the x-axis. Okay, now let us calculate S. It is, as we are told, it is A over B. So it is A over B. 6.5 divide 38.5. 0.169. And why do I keep it to three significant figures? Notice we have three significant figures over here and have the two significant figures for over here. So we keep it to three significant figures. Okay. What is the next one? 11.2 divide 33.8. 0.331. 0.331. That's the next one. 15.2 divide 29.8. 0.510. 0.510. 17.1 divide 27.9. 0.613. 0.613. And we have 20 over 25. 0.800. Okay, we have all of them consistent with three significant figures. So now let us choose the graph. Plot a graph of S so and so, determine the gradient of so and so. So maybe a good choice, because we have 20 over here, can start right from 0. Okay, 20, 40, 60, 80, 100. And this is M in grams. We have 0.16 and 0.18. So we are going also to go from 0. Okay, so we have 0.8 divide 5. 0.8 divide 5 squares. 0.16. 0.16 is not a good choice of a scale. The next best one is 0.2. So we make a scale over the y-axis as 0.2. 0.2, 0.4, 0.6, 0.8, and this is in S. And S doesn't have any units. Okay. Now let us start making the plotting our points. It is 20 and 0.169. So again, maybe counting might be a little bit of challenge over here. So let us see how we can plot this first point. This first point, we know it is somewhere over here, right? So it is 0.169 minus 0 divided by 0.2. 0.169 divide 0.2, 0.845. So we get this first data point, this first value is 8 squares, small squares, okay, and 45 we round it to 5, so it is between the square number 8 and square number 9. So it is over here, and we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it is in between over here. Okay. Now for the next point, it is 40.331. 0.331, and we know it is between over here. Okay, so the closest scale mark is 0.2 minus 0.2 divide 0.2. From where are going to get this 0.2? It is the scale on the y-axis. 0.331 minus 0.2 divide, 0.331 minus 0.2 divide 0.2, 0.655 or 0.66. What does it mean? 6 small squares, and it is closer to the 7 marks than the 6. Okay, then it is 4. Let us count. 1, 2, 3, 4, 5. This is number 6, and it is between over here. It is almost here. Okay. Now we have 60 and 0.51. So we have 0.51. What is the closest scale mark? It is 0.4. 0.55. Again, 5 small squares, and we are in between the 5 square marks and the 6 square marks. So it is 1, 2, 3, 4, 5, 6, and it is in between over here. Okay, now let us go to the next point. It is 80 and 0.613. So we know it is around here. Okay, or better saying, it is around here. Okay, this is 80 and 0.613. It is closer to the 0.6. 0.613 minus 0.6 divided by 0.2. 0.613 minus 0.6 divide 0.2. 0.065. 0.065. So it is not even as a 1 square, okay, but it is closer to the 1 square scale mark away from 0.6. So it is over here, and it should be around here. Okay. Now we have 100 and 0.8. This is easy, straightforward. This is the 100, and this is the 0.8. It is over here. Oh, huge. Okay. Now let us make the graph. Sorry. I think this should be a good line. Okay. Now we calculate the gradient. We calculate the draw a right angle triangle. It's our right angle triangle. Okay. Again, it is delta x, delta y, sorry, delta y, and delta x. Okay. For delta y, we have 0.7, 0.72. Okay. 0.72 minus this is 0.2 is equal to 0.52. What about the x-axis? This is the 90 mark. Okay, this is 20, 22, 24. This is 90 minus 24. Okay, then it is 0.52, and here we have 66. So the gradient is equal delta y divide delta x. It is going to be 0.52 divided by 66. Okay. 0.52 divide 66. 0.0078. 0.0078, and we need to take the units. So on the x-axis we don't have on the y-axis we don't have units. On the x-axis we have units, so it is gram minus 1. Now let us go to the next question. So for each value of d, calculate 1 over d. And record it in the table. Okay. So we have 1 over d. Let us do the calculation. $30.2. It is 0.0331. We are keeping 3 significant figures since we have 3 significant figures over here. 0.0331. We need to complete the table. 1 over d is in units of centimeter minus 1. For this one, the inverse of 23.9, I'm going to do it quickly. 418. This one, 20.0500. Over here, 17.1, it is 0.0585. 15.1, 0.0662. Okay. What do we have? We have m on the y-axis, 1 over d on the x-axis. So this is x-axis, this is y-axis. Okay. We have 1 over d, centimeter minus 1, and we have mg over here. Okay. Now, we were not asked to either start from the 0. He is not telling us. So how we are going to decide for that? Okay. So if we start the y-axis from 0, you are going to see that you are almost going to get half of the y-axis without any data points. Okay, because going to go from 0 to 40. We don't have any points, but 40, all our data points are from 40 to 80. So if we start the y-axis from 0, we are not, we are almost getting half of the graph plot empty. Okay, so it's not a good choice. What we are going to do on the y-axis, we are going to go start from 30, 40, 50, 60, 70, and 80. Okay, this for the y-axis. What about the x-axis? Might be difficult to get it without doing some calculation. So we're going to go the maximum minus minimum, and we divide by the number of squares. So what is the maximum? 0.0662. What is the minimum? 0.0331. Okay, how many squares do we have? We have 5 squares. Okay, let us do the math. 0.0662 minus 0.0331, and we divide by 5. 0.0062. Okay, so 0.0062 is not going to be a good choice. The next best one is to round it up to 0.01. Okay, 0.01. And we are going to start from where? We are going to start from 0.03. Okay. Now, we have on the x-axis 0.031. Okay, how to calculate it? As we did before. Okay, 0.0331 minus this over here, 0.03, and we divide by the scale 0.01. Point 31. What does it mean? It is 3 small squares away from the 0.03 mark. Okay, and 1 very close. So it is 40, and it is over here 3. 1, 2, 3 around here. Okay, so 0.0418 minus 0.04 divide 0.01. 0.018. Okay, so it is 50 around here, and we are 0.18, almost 2 small squares. We are around here. Sorry. Around here. Okay. 0.0560. This is easy. It is around here. What about 70 and 0.585? 0.0585 minus 0.05 divide 0.01. 0.0585 minus 0.05 divide 0.1. It is 0.085. .85. Okay, so we start counting. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is in between 8 and 9. What about the last data point? It is 0.0662. What is the closest scale mark? It is 0.06. 0.2, 0.02, 0.01. Point 62. Again, meaning 6 squares, small squares. Okay, and a little bit to the right. This is the 80 mark on the y-axis. It's 5, 6. Okay, now we have our line. Let us calculate the gradient. We again draw a right angle triangle. Is our right angle triangle. Again, we calculate delta y and delta x. For delta y, we have this data point. It is 70, 71, 72. This 72 minus this 40, 45. Okay. What about the x? It is 0.0x, 0.06 and 0.35, 36, 37, 0.037. Okay. So delta y is 27. This one is 0.06 minus 0.037. It is equal 0.023. Okay, so the gradient is equal delta y divide delta x. Delta y is 27. Delta x is 0.023. We do the math. (27) divided by 0.023. 1173 or 1174. 1174. Now we need to check the units. The units is delta y divide delta x. So delta y is grams divide delta x is centimeter minus 1. So you can leave it like this, or you can get the centimeter up, 1174 grams centimeters. Okay. So the more you practice doing the graph plots, the easier it get. Okay. So I hope this video was useful for you, and see you again. Cheers.